Okay, the live stream has started. We'll start at 8 a.m. in about 5 minutes. This looks a little close. I need to raise it up a little, I think. Well, if I stay out of the margins, I should be okay. Hallie Nicholson. Kayla Shook. Chloe Wilbur. That's you. Jack Winters. Joseph Bond. Alexander Perez. So I'm hitting on all cylinders so far. We'll start in about 1 minute. So if you're watching on YouTube Live, go ahead and sign in for attendance. Okay, it's 8 o'clock. Today we'll be in section 3.1. We'll discuss how to graph linear equations. On Monday, we'll also be in section 3.1. with more information about graphing linear equations. But first, we will discuss a rectangular coordinate system. Okay, a rectangular coordinate system consists of a horizontal number line and a vertical number line. Well, in the larger scheme of things, we don't have to use the variables x and y, but we're going to use the x variable to describe the horizontal number line, which is called the x-axis, and the vertical number line is the y-axis. So we're using the variables x and y. The x-axis and the y-axis together form what we call the xy plane. So the xy plane, by plane we mean a two-dimensional space. So I'll just write 2 dimensions. The point where the x-axis intersects the y-axis is called the origin. So I'll draw some pictures a little bit later, but you can visualize the x-axis being horizontal and the y-axis being vertical, and the point where they intersect, we refer to that as the origin. The positive x values are on the x-axis to the right of the origin, and the negative x values are on the x-axis to the left of the origin. And the vertical axis also has orientation regarding positive and negative numbers. So on the vertical axis, or the y-axis, the positive y values are on the y-axis above the origin, and the negative y values are on the y-axis below the origin. Every point in the xy plane corresponds to an ordered pair of the form x comma y in parentheses. So the placement of that point in the plane is determined by a rectangle, in effect. From the origin, we would move either to the right or to the left, depending upon what the value of x is. And then we would either move upward or downward, depending upon what the value of y is. So we'll look at how to plot points in a few minutes. But just remember, every point in the xy plane corresponds to one and only one ordered pair, x comma y in parentheses. Okay, an ordered pair consists of an x coordinate and a y coordinate. So for our purposes, the x coordinate is on the left, the y coordinate is on the right. The origin, where the x-axis intersects with the y-axis, it is a point in the xy plane, and the ordered pair for the origin is 0 for x and 0 for y. Okay, another bit of information. The xy plane is subdivided into 4 quadrants. Quadrant 1, or the first quadrant, is the upper right part of the xy plane. And then from there we move counterclockwise. Quadrant 2 is the upper left part of the xy plane. Quadrant 3 is the lower left part of the xy plane. And quadrant 4 is the lower right part of the xy plane. Okay, so I will finally draw a picture. So we have a vertical axis, which we are going to call the y-axis. I'll just put the variable y here. And then we have a horizontal axis that we call the x-axis. So the horizontal axis, or the x-axis and the y-axis, they intersect to form a right angle, or a 90-degree angle. Okay, so let's plot these points. We have 5 ordered pairs. So we can all make markers for the positive and negative integers in all directions first. So if you can read my writing, I'm going to, on the positive x-axis, that's to the right of the origin, I'll label these points 1, 2, 3, 4, 5, and so on. To the left of the origin on the x-axis, -1, -2, -3, -4, -5. The positive y values are above the origin, so on the y-axis, moving upward, we have 1, 2, 3, 4, and so on. And then below the y-axis are the negative y values, so -1, -2, -3, -4. The x-axis looks like the ordinary number line that we're familiar with, but the y-axis is also a number line. It's just a vertical number line. Okay, to plot the number, or to plot the ordered pair -5, 4, we can do it systematically. The x-coordinate is -5, so from the origin we move on the x-axis in the negative direction until we get to -5. The y-coordinate of that point is +4, so that means from here we move vertically upwards 4 units, and we get this point. So I'll go ahead and label it. It's the ordered pair -5, 4. So which quadrant is this point -5, 4 in? Yeah, it's in the second quadrant. So we can label the quadrants. The upper right is the first quadrant. The upper left is the second quadrant. The lower left is the third quadrant. And the lower right is the fourth quadrant. Okay, the next point to plot, the ordered pair -3, -4. So the x-coordinate is -3. So from the origin, move to the left till you get to -3. The y-coordinate is -4, so we move downward 4 units. And we stop here. And I'll go ahead and label it -3, -4, which is in the third quadrant. The next ordered pair, 0, -1. The x-coordinate is 0, so from the origin, we don't move either to the right or to the left. We just stay at the origin. The y-coordinate is -1, so we move down 1 unit. So now we're at the ordered pair 0, -1. This point, 0, -1, is not in a quadrant, but it's on the y-axis. So one thing to pick up from this example, Every point on the y-axis has an x-coordinate of 0. That's a small detail, but a very important detail, as it turns out. Every point on the y-axis has an x-coordinate that's equal to 0. Okay, so don't dismiss that as something that's trivial. Remembering that can save you a lot of trouble a little bit later on. Okay, the next ordered pair, 3, 2. So x is 3, y is 2. So from the origin, we move to the right 3 units, that is in the positive direction. Then we move vertically upward 2 units. So at this point, whose ordered pair is 3 for x and 2 for y, this is in the first quadrant. And then the final point in this little exercise, the ordered pair 1, 0. So where is that point in the xy plane? Which quadrant is it in? It's not in a quadrant, but where is it?
X-axis number 1.
Yeah, it's on the x-axis. So the point 1, 0, from the origin, since the x-coordinate is 1, we move to the right 1 unit. The y-coordinate is 0, so we just stay on the x-axis. So we get this point, I'll label it 1, 0. Hey, so from this example, the ordered pair 1, 0, which is on the x-axis, what can you say in general, do you think? Another little small detail, but a very important detail. Every point on the x-axis has a y-coordinate that's equal to 0. So remember that. Every point on the x-axis has a y-coordinate that's equal to 0. A little bit earlier, we saw that every point on the y-axis has an x-coordinate of 0. Okay, that's how you plot points. And plotting points is one of the ways that we're going to graph linear equations, by plotting points. Okay, so the next page, we have a definition of a linear function, or a linear equation. A linear equation in the variables x and y can be written in the standard form ax plus by equals c, where a, b, and c are constant real numbers, and a and b are not both 0. It's okay if either a or b is 0, but we can't allow capitals A and B to both be 0 at the same time. Otherwise, if we did that, we wouldn't have a linear equation. Okay, here's an example of a linear equation in the variables x and y that's in standard form. The equation 4x plus 6y equals 12. So in this example, a is 4, capital A is 4, capital B is 6, capital C is 12. Okay, if we have a linear equation in the variables x and y that's not in standard form, we can always do something to get it into standard form. So here is a linear equation in the variables x and y. Y equals negative 2x plus 7. it's not in standard form, but it's still a linear equation in the variables x and y. So how can we get it into the form ax plus by equals c?
Move the 2x to the other side.
Yeah, all we have to do is add 2x to both sides, and then we're done. So there's just one step to get it into standard form. Add 2x to both sides, and we get 2x plus y equals 7. So now it's in standard form. Okay, a solution to a linear equation, ax plus by equals c, is an ordered pair, x comma y in parentheses. So here's a note. A linear equation, ax plus by equals c, has infinitely many solutions. That means there are infinitely many ordered pair solutions to a linear equation. Okay, what do you suppose is meant by this statement? In other words, what more could be said about this definition of a solution? It's actually not quite a complete definition. It's true, a solution to a linear equation, ax plus by equals c, is an ordered pair, x comma y in parentheses. But what makes it a solution? So above this sentence, I'll write down a little bit more information. So if the ordered pair xy is a solution to ax plus by equals c, then replacing x with the x-coordinate of the ordered pair and replacing y with the y-coordinate of the ordered pair will result in an equation that is true. Okay, so then I'll just write down what I just said. Then replacing x in ax plus by equals c with the x-coordinate of the ordered pair, you're going to run out of room. And replacing y in ax plus by equals c with the y-coordinate of the ordered pair, I'll find a place to put this. With y, okay, I'll continue down here with the y-coordinate of the ordered pair results in a true equation. Or I'll just say results in an equation that is true. That seems to make sense, doesn't it? We've learned how to solve linear equations in one variable. We did that a few days ago. Something of, for example, 2x plus 6 equals 0. That's called a linear equation in one variable. So the solution is the number that you replace x with that makes that equation true. Well, if you have a linear equation in two variables instead of just one variable, you have to be able to replace x with a number, replace y with a number, and then get an equation that's true. It's the same concept, just with one extra variable. Okay, so let's work on this exercise here. Let's find 10 ordered pair solutions to the equation 3x plus 2y equals 6. Remember my note from above? A linear equation, ax plus by equals c, has infinitely many solutions, infinitely many ordered pair solutions. So we only have to find 10, so that's reasonable. If there's infinitely many and we only have to find 10, it's not bad. So how do you propose to go about finding a solution? Well, for linear equations, ax plus by equals c, I'll just give you a little bit of inside information. If a and b are non-zero, which is what we have in this case, a is 3 and b is 2, so they're non-zero. We can start out by picking x to be any number we want between negative infinity and positive infinity. And then as soon as we pick x, that will determine one and only one value for y. But to start with, we have freedom to choose x to be any number we want between negative infinity and positive infinity. We replace x with that number and then solve the resulting equation for y. And then the ordered pair that we get is called a solution to that linear equation. Alternatively, if you don't want to pick x to be anything you want, you can pick y to be any number you want. And as soon as you pick a specific value for y, replace y with that number, solve the resulting equation for x, and we'll get another ordered pair solution. So one thing you'll learn how to do is, with practice, you'll learn how to pick x and y values in a strategic way so that the arithmetic is simpler as opposed to more difficult.
And then with this, is it okay to have like fractions and decimals as like your x or y?
You're free to use any numbers you want, but I'm not going to. I'm going to pick numbers that make the arithmetic easy. Yeah, if you want to pick x to be 1/41st, go right ahead, but I'm not going to do that. So one thing we can do, we can create a table of x and y values. So x is on the left, y is on the right. So I'm looking at this equation, 3x plus 2y equals 6. So I'm going to pick x to be, I'm going to pick x to be 2. And then in the equation, 3x plus 2y equals 6, I replace x with 2. So I get 3 times 2 plus 2y equals 6. Or 6 plus 2y equals 6. Subtract 6 from both sides. I get 2y equals 0. Divide both sides by 2, I get y equals 0. So the ordered pair 2, 0 is a point, or is a solution. Okay, in the left column, I'll write these as ordered pairs, x comma y in parentheses. So we found the ordered pair 2, 0 is a solution to that equation. Okay, well, maybe we won't find 10 because we do want to do some other things. But let's find a couple more. Let's see, this time I'll pick x to be negative 2. And then in the equation, replace x with negative 2. So we get 3 times negative 2 plus 2y equals 6. 3 times negative 2 is negative 6, so I'm going to add 6 to both sides, and I'll get 2y equals 12. And then divide both sides by 2. We get y equals 6. So we get the ordered pair negative 2, 6. So I wouldn't say that picking x to be negative 2 is the best choice if I want arithmetic to be easy. If I want arithmetic to be really easy, I'm going to pick x to be 0. So if I pick x to be 0, then what's the y coordinate that goes with it? Okay, so if x is 0, 3 times 0 plus 2y equals 6. 3 times 0 is 0, so 2y equals 6, divide both sides by 2, we get y equals 3. Okay, so we have 3 solutions, 3 ordered pair solutions. One is 2, 0. The second one is negative 2, 6. The third one is 0, 3. Okay, so let's plot these points. We should be able to get the idea of what's going on if we plot these 3 ordered pairs. If we do it so it's at least believably accurate. Okay, so one of the ordered pairs is 2, 0. That's this point right here, 2, 0. The next ordered pair, negative 2, 6. So here's negative 2, 6 is up there. So negative 2, 6 is in here, right in here somewhere. And then our third ordered pair solution, 0, 3. So that's on the y-axis. So 0, 3 is this point. So what do you suppose is true about all of the other infinitely many solutions? So we just plotted 3 points, 3 ordered pairs that are solutions to that linear equation. What would happen if we were able to plot all infinitely many ordered pair solutions? What would happen is they would all be on a straight line. So this is supposed to be a straight line through those 2 points. Those 3 points are all on the same straight line. So that should not be a surprise if you remember that we refer to the equation as a linear equation. So the graph of a linear equation in the variables x and y, the graph is a straight line in the xy plane. That's why we use the term linear equation, because its graph is a line. So I'll write that statement down here. The graph of ax plus by equals c. Well, the implication is that the graph is in the xy plane. The graph of ax plus by equals c is a straight line in the xy plane and the graph itself represents the infinitely many solutions. It passes through all of the solutions, all of the ordered pair solutions. Okay, let's move on to the next page. A little bit more information about graphing linear equations in the variables x and y. Okay, so as has been stated, the graph of a linear equation ax plus by equals c is a straight line in the xy plane. So in order to graph a linear equation, ax plus by equals c in the xy plane, only two distinct points are needed. So a little bit of, I'll add to this a little bit. So that is two ordered pair solutions are needed. That's enough to graph a straight line, two ordered pair solutions are needed to graph the straight line. Okay, so why is that? Maybe you might have learned in a geometry class, Euclidean geometry, also called plane geometry, that is two-dimensional geometry. In a plane, one and only one line passes through two distinct points. So as long as you have two different points, that's enough to be able to graph the line that passes through those 2 points. Okay, so let's graph the equation y equals 4x minus 1 by plotting points. This is a linear equation in the variables x and y. It's not in standard form. We don't need to put it in standard form in order to find two ordered pair solutions. You can if you want, but you don't have to. So if we graph this linear equation in the variables x and y, all we need to do is find two ordered pair solutions. So I'll create a column for the xy ordered pairs, and then another two columns, one for x coordinates, the other one for y coordinates. So we're just going to pick x to be a number, replace x with that number in the equation, and simplify to find the y coordinate. And then once we have the x and y coordinate of a single point, we can plot that in the xy plane. Then we'll find another ordered pair. Okay, we have infinitely many choices, but let's pick something that's simple. If I pick x to be 1, picking x to be 1 is often a convenient choice. Then in the equation, replace x with 1, so we get y equals 4 times 1 minus 1, which simplifies to 4 minus 1, or 3. So we can use the ordered pair 1, 3 as a point on that line. Now all we have to do is find one more point, one more ordered pair. Okay, how about if I pick x to be how about x to be -1? That's not the most convenient choice, but it'll give us a little opportunity to practice with negative numbers. So if x is -1, to find the y coordinate that goes with -1, in the equation, we just replace x with -1. So we get 4 times -1 minus 1. 4 times -1 is -4. -4 minus 1 is -5. So we get the ordered pair -1, -5. Okay, 2 points, 2 ordered pairs that are solutions to the equation. That's enough to graph the line. So we'll fill in some of these numbers in the xy plane. It'd be nice if I drew a bigger graph, but the ordered pair 1, 3, the ordered pair 1, 3 is right here in the first quadrant. The ordered pair -1, -5 is about right here. And then if you have a ruler, you can graph the equation. So that's supposed to be a straight line. Here, the next example of a linear equation, y equals -x/3 minus 3. I'll use this example to show you how you can pick x coordinates that will make the arithmetic a little bit easier. So we'll just find 2 ordered pair solutions. So on the right-hand side, okay, on the left-hand side we have y. On the right-hand side, that's equal to -x/3 minus 3. Since I'm dividing x by 3, it will be more convenient if I pick x to be a multiple of 3. So if I pick x to be 3, just 3, and then always watch out with the arithmetic involved. So we have negative, and then replace x with 3. So the negative of 3/3 minus 3. -3/3 is -1. So -1 minus 3 is -4. So I get the ordered pair 3, -4. Another multiple of 3 that we could use x, or that we could replace x with, we could use 6. 6 is a multiple of 3. That makes the arithmetic fairly simple. So we could do that. I'm going to pick x to be -3. And then just be careful with the arithmetic. So if I pick x to be -3, I get y equals the negative of -3 over 3 minus 3. -3 over 3 is -1, and the negative of -1 is 1, so I get 1 minus 3, or -2. Okay, so we have 2 ordered pairs. One ordered pair is 3 for x, -4 for y. The other ordered pair is -3 for x and -2 for y. Okay, so let's graph that by plotting those 2 points. Okay, the ordered pair 3, -4. It's about right there. 3, -4. The ordered pair -3, -2. It's about right there. And then draw a straight line through those 2 points. Yeah, the concept is pretty straightforward. One of the things that can make it difficult is the arithmetic. So make sure you practice the arithmetic. Okay, the next one, graph the equation y equals 2. The variable x is missing. So this is a case if you had ax plus by equals c. This is a case where the number a is 0. So it's still a linear equation, ax plus by equals c. This time a is 0. B is 1 and C is 2. Okay, the graph is still a straight line. The line consists of ordered pairs where each ordered pair has a y-coordinate equal to 2. So x could be anything. As long as the y-coordinate is 2, x can be anything. So I'll just pick x to be -2. When x is -2, y is 2. When x is +2, y is 2. So if we plot those ordered pairs, -2, 2, and +2, 2, what kind of line do we get? So -2, 2 and +2, 2. Well, this is supposed to be a horizontal line. So the line y equals 2 in the xy plane is horizontal. The y coordinate of every point on that line is 2. So the equation y equals 2 basically tells us that it's a horizontal line. Every y coordinate is 2. Okay, what about this one? Graph the equation x equals -3. This time, if we have ax plus by equals c, this time b is 0. So b is 0 in this one. But the graph of this is a straight line in the xy plane. It's just that every point has the same x coordinate of -3. So if every x coordinate is -3, well, I can pick any 2 points I want. I'll pick these 2 points. So the ordered pair of that one is -3 for x, 1 for y. The ordered pair for that one is -3 for x, 3 for y. I could have picked other points besides those. I'm just making sure that the x coordinate is the same, -3. And the graph is a vertical line. So this is the vertical line, x equals -3. Okay, so it's almost time to quit. We'll do part of the next exercise. The ones that follow, like this one down here, graph the equation 4x plus 2y equals 2. You can just do what we've did on the previous examples. Pick x to be a number, replace x with the number, solve for y to get an ordered pair solution. Then pick another number for x. If you want, you could pick numbers for y instead. Just find 2 ordered pairs. But let's start this one. Determine if the ordered pairs are solutions to 5x plus 9y equals 4. Okay, so let's start with 7 for x, -31/9 for y. So we're testing to see if this is a solution. So in the equation, replace x with 7, replace y with -31/9. And we want to know, is this true or false? So we just do the arithmetic. Okay, so 5 times 7 is 35. And here, plus 9 times -31/9, we can cancel the common factors 9, and we're just left with plus -31. And it looks like we're going to get a true statement because 35 plus -31 is 35 minus 31. And this is true. So this just means that the ordered pair 7 for x, -31/9 for y is a solution. Then you can do the same approach for the other 3 points to see if any of the others are also solutions. Okay, that's all for today. On Monday, we'll also be in section 3.1, so we'll graph more equations on Monday.